Hello, and thanks for checking out Chemistry Connections on the Hopewell Valley Student Podcasting Network, a proud partner of hvspn.com, where students come together to publish content to share with the world. The opinions represented within this episode are those of the content creators only. Please enjoy the show.
Welcome to Chemistry Connections. My name is Olivia and I am your host for episode 4 called The Chemistry of Cotton Candy Grapes. Today I will be discussing what acids are within a grape and how cotton candy grapes are made. Cotton candy grapes are a variation of green grapes whose flavor is compared to the carnival fluffy sweet confection cotton candy. The process of turning a regular grocery store grape into a cotton candy grape is called hybridization. The common belief among people is that grapes are produced by injecting artificial flavoring. However, the cotton candy taste is through plant breeding. Hybridization happens between two different grape species, a type of Concord-like grape, which can be seen in Welch's jams, jellies, and juices, and a variety of Vinis and Farina, an everyday grape found in grocery stores across the country. A horticulturist is responsible for this process. Horticulturists are specialists with training in plant productions and development who monitor and enhance the growth of high-quality foods, plants, decorative plants, and medicinal herbs. These medium-sized oval or oblong grapes are seasonal fruits. They are also lacking seeds by default. We'll cover everything that makes people wonder about the odd characteristics of these grapes, including their structure and sugar content. First, let's discuss what a grape really is. Grapes are made up of 70 to 80% of water, and they're made up of acids, which includes tartar, malic, and citric acid. Green grapes are more acidic with a pH range of around 2.4, while red grapes have a pH of 5.5 through 7. Since it has 7 in its pH range, this means that the red grapes could be neutral. Acids contribute to the overall acidity, giving refreshing and a tangy taste. But what is an acid? An acid is created when substances dissolved in water increase the H+ ions in the solution. Donation of protons by acids, which is the Bronsted-Lowry theory, have a pH of 0 through 14. Acids are less than 7 on the pH scale, and this is determined by the H+ concentration. They also have different elements such as corrosive nature. An example of this could be rocks and their ability to conduct electricity. And acids can conduct electricity when they're dissolved in H2O. The hydrogen acts as a proton donor, which lowers the pH. Acid-base reactions happen when an alkaline substance produces salt and water. This is also called neutralization. There are 7 strong acids, and all 7 acids completely dissociate in H2O, while weak acids only partially dissociate, which results in a lower concentration of hydrogen. Grapes have pH values that range from 1.9 to 4, which makes them an acidic fruit. These acids are at their highest concentration when the grapes are unripe, and an acid content decreases as they mature. One of the acids in grapes, malic acid, has an ionizable hydrogen on each end of the molecule. This H dissociates and attaches to water molecules, making H3O+, which then the tongue detects as a sour taste. Malic acid has 2 ionizable hydrogens, but why do those hydrogens break off? First off, the dissociation of hydrogen and malic acid or any other acid depends on the acid strength. Diprotic acid, which is 2 acidic hydrogen atoms, can dissociate in an aqueous solution. Because malic acid is weak, and weak acids only partially dissociate, which lowers the concentration, both hydrogens must have 2 different Ka values. Ka1 has to be larger than Ka2, so the first hydrogen dissociates faster than the other. In 2011, cotton candy grapes were first introduced to grocery stores. Vinis, Farina, sugars, and esters are responsible for giving their sweet flavor. Glucose and fructose are the main sugar compounds in the juice of grapes. At a ripening stage, the ratio of glucose to fructose is about 1:1. In overripe grapes, the concentration of fructose is greater than that of glucose. Esters are mainly responsible for the flavoring of cotton candy grapes. An ester is a compound derived from acid ethyl acetate, which can be organic or inorganic. H or OH is replaced by R which represents the organyl group, which represents any carbon or carbon chunk. Organic compounds are formed by the reaction between alcohol and acid, contributing to their flavor. Common esters in cotton candy grapes include ethyl butyrate, which gives a fruity aroma of an apple, and ethyl hexanoate, which gives sweet notes. During the ripening process, enzymes that are present in the fruit catalyze, which causes the formation of esters through alcohol molecules which are naturally present. The presence of specific esters in cotton candy grapes can vary due to genetic factors, environmental conditions, and agricultural practices. Higher levels of esters in cotton candy flavors are due to sugars and acids, which also contribute to the overall taste. Ethyl butyrate, also known as C6H12O2, is bonded together through covalent bonding. Pi bonds are present, which overlap the atomic orbitals, and the C and O bond together through a double bond, and there's also one sigma bond through the sp2 hybridized orbital of O2. Unhybridized p orbitals overlap, creating a pi bond, causing reactivity in chemical properties, which allows rotation around the sigma bond in behavior. The sigma bonds are C, H, and O, and this is a type of bond of two covalent chemical bonds formed by an overlapping atomic orbitals along the axis connecting the nuclei of the two atoms. It is the strongest type of covalent bond and is commonly found in single bonds between atoms. Multiple bonds can be formed between atoms, such as a double or triple. These involve the formation of at least one sigma bond and other pi bonds, which result from the parallel overlap of p orbitals. Sigma bonds are always the first to be formed before pi bonds. Other bonds within the carbon chain are C to C, C to H, which are only single bonds, while C to O is a double bond, which allows the atoms to share electrons, and this makes covalent bonds. The C chain on both ends are tetrahedral, and the oxygen bonded to the carbon is polar, which was also the double bond. O is negative, while C is positive. However, the overall molecule is nonpolar. Around the oxygen, there are 4 electrons. Welcome to the crossover section of this podcast. This is the joke section. Hey, Dorothy.
Hi.
What did grape say if you step on it?
What?
It wouldn't say anything. It would just let out a whine.
Okay, that's pretty bad.
Do you want to hear another one?
I guess.
Okay. Why would a Miss Grape leave her children behind?
You tell me.
Because she loves raisin kids.
I hate raisins.
Okay, that sounds like a you problem.
Oh, thanks.
Okay, I got another one for you. What happened when the grape was promoted?
What's the question?
It got raisin pay.
I told you I hate raisins.
Okay, I have another one that doesn't have to do with raisins.
Thank goodness.
What is purple and huge and swims in the ocean?
A grape?
Moby grape.
Well, thanks for that.
Yeah, sure, anytime. This is the end of our joke section.
And have a good day.
Bye. The reason why I chose this as my project is because I was really interested in cotton candy grapes and how they are made. My mom would never buy them from the grocery store because she thought they were injected with artificial flavoring, but obviously this is not true, as it is learned that the cotton candy grapes are naturally made through horticulturists. Thank you for listening to this episode of Chemistry Connections. For more student-run podcasts and digital content, make sure you visit www.hvspn.com.